Hello learners, welcome to Sure Question Academy. Please watch the videos, like and subscribe to the channel.
Hello. Let's look at an interesting question about the refraction of light. The question has two parts. Let's first read part A. It asks us to state the two laws of refraction of light. Okay, let's answer part A first. Do you remember the laws of refraction? The first law states that the incident ray, the refracted ray, and the normal to the surface at the point of incidence all lie in the same plane. Moving to the second law, which is also known as Snell's law. It states that for any given pair of media, the ratio of the sine of the angle of incidence to the sine of the angle of refraction is always a constant. Mathematically, sine I divided by sine r equals constant. Now, there is an OR option. Let's check that out. Part B asks us to define absolute refractive index and then solve a numerical problem based on it. Let's answer part B first. What exactly is absolute refractive index? It is simply defined as the ratio of the velocity of light in a vacuum to the velocity of light in that specific medium. Mathematically, we can write this formula as N equals C divided by V. Great. Now, let's solve the numerical part. As always, let's first write down what is given in the question. The absolute refractive index of glass, N, is given as 1.5. And the speed of light in vacuum, C, is given as 3 into 10 raised to 8 meters per second. What do we need to find? Yes, the speed of light in glass. Let's call it V. From our definition, we know the formula N equals C divided by V. Since we need to find V, let's rearrange this equation. V equals C divided by N. Now, let's substitute the given values into our equation. V equals 3 into 10 raised to 8 divided by 1.5. When we divide 3 by 1.5, we get exactly 2. So, the value is 2 into 10 raised to 8 meters per second. Therefore, the speed of light in the glass medium is exactly 2 into 10 raised to 8 meters per second. Thank you. Happy learning.